The aim of this project was to design and build a robot that would move on a table and self-correct every time it reached the edge of the surface so it wouldn't fall off. For the frame of our robot, we used a lightweight plastic that was easy to cut. The shape we decided on was a T-shape in which we could mount the sensors on the fins to detect when the robot was over an edge. The wheels are attached at the back to two DC motors. The motors were fastened to an independent bracket before attached to the frame, so that they would be properly aligned and the robot would move in a straight line. The small breadboard was glued to the back of the frame to house all of the electrical components. Some extra amenities that we added were a power regulator, so that we could use a 9-volt battery to power the DC motors, as well as the 5-volt PIC processor and a power switch.
So for the electronic parts used, we have a PIC16 F690, which handles all the processing power. We have a LED array. This is to help us debug the whole system in development. We have a motor driver to power the motors. We have 5-volt regulators. This converts our 9 volts from our DC and converts it to 5 volts for our logic. And last, we have a quad comparator, which helps us detect any edge from for the sensors.
I'm going to discuss how we designed the logic of our system. Because we are using 2 sensors, our system can receive 4 different readings that tell the robot how to react. The first reading that our robot could receive is that both of the sensors detect a surface. In that case, we would instruct the robot to move forward. If the right sensor detects a surface and the left sensor doesn't, then that means that we need to turn to the right in order to get the left sensor onto the surface. If the left sensor detects a surface and the right sensor doesn't, then we need to turn left to get the right sensor back on the surface. If both of the sensors do not detect a surface, then the robot will reverse and then turn to the right in order to prevent it from getting into a non-ending loop of going forward and reverse over that surface.